Alrighty guys, today we're going to be solving a quadratic equation. If your question is, I got to the end of my activity today, I'm not really sure what they're talking about in terms of this third way of finding the solution, this video will really help you out. If you have no idea what a quadratic is, this video will really help you out. So let's just get started. So for our lesson, we're talking about quadratic equations. We've seen a few of these so far this year, but we haven't quite put a name to it. So we are going to talk about solving and what they are. Okay. So let's do it. A quadratic equation is any equation with the form ax squared plus bx plus c. So that is a quadratic expression. We're making it an equation by setting it equal to 0. By doing this, we're actually figuring out the specific x values that make our quadratic equation 0. So this is a special case. Usually we'll have y equals ax squared plus bx plus c, and then we're talking about a quadratic equation in general. But here we specifically want it equal to 0 for the rest of this lesson. Let this refocus real quick. Okay. So, what we can do with this, the big thing with the quadratic equation is that our x squared is going to be our leading term. So anytime you see an equation with a leading term of x squared, you know you're talking about a quadratic equation. Some examples could be like y, or yeah, let's do some function notation. So f of x equal to x squared. So that's the most simple one. Remember, if there's no number in front, that just implies that we have a 1 in front. So in here we have a quadratic with a leading term, or a leading coefficient of 1, or the number in front of our leading term, b is equal to 0, and c is equal to 0. More complicated one we might come across is another function, maybe g of x, where we have 3x squared minus 2x, so minus 2x plus 1. So in this case, our a is equal to 3, our b is equal to negative 2, and our c is equal to 1. So notice how every single time we have a leading term of x squared. So it's really useful in this case to figure out how to solve for x. So there's two ways to solve for x. In the specific case where we have our quadratic equal to 0. One is factoring. The other is the quadratic formula. So we're going to start off with the factoring, go over that a little bit, and then go on to the quadratic formula. You should have had a little bit of factoring in Algebra 1, but this should be overall new stuff, new review. So in this example, we are going to do the expression x squared minus 3x minus 10 equal to 0. And what we're going to do with this thing is actually find the values of x which make this a true statement. Or in other words, if I plug in x values into my left side of my equation and then do all the arithmetic, it should come out to 0 if we're having a true statement happening here. Or in other words, 0 should, on the left, simplified, should equal the 0 on the right to be true. So, one thing I'm going to do before we get started is really emphasize what our A, B, and C is here. So I'm going to switch, let's keep going with the blue. I'm going to have a 1 x squared. And so notice that these are all adding, so plus a negative 3x, and then plus a negative 10, which is all equal to 0. So we're trying to figure this thing out. We're trying to figure out how to change this into a form that looks like x plus some term times x plus some other term. Because then that'll get us one step closer to figuring out what those x values are. So we're checking these out, and the first thing we want to do is make our, explicitly figure out what our a, b, and c is. So we have an a equal to 1, a b equal to negative 3, and a c equal to negative 10. So from here, we can start filling in this little diagram. You guys might have seen this from kind of games that you might have played earlier on in middle school and elementary school. But we're trying to find two values here. One value right here, one value right here. And these two values need to follow a set of rules. The first one is they have to multiply up to the top value. So this top value is specifically a times c. So you pull them out of your quadratic and standard form. You want to put them in your top value. The next thing that these two numbers have to do is add to the bottom value. So that's going to be your middle term, the one attached to the x. So you want to satisfy both of these at the same time. And if you do, then you have your two values you can put into here. One right here and one right here. And from there you can finally solve this thing and figure out which x values will do this. So let's recreate our graph, or our crisscross, with the numbers we have. So a times c, well, that's just 1 times negative 10. So we got a negative 10 up here, and we have a negative 3 down here. Through practice, you can start getting pretty good at seeing exactly what it is. But at the beginning, it might be worthwhile to just run through your factors and test. You always want to start off with the testing multiplication ones, and then seeing if they add up to the bottom term. If you try to do it the other way around, you're going to get a lot more options. There's only a few where you can multiply up to negative 10. So let's start off with a relatively straightforward one. Let's try some values like 10 and negative 1 maybe. So we test it out. We know intuitively that 10 times negative 1 is negative 10, so we're good on the first roll. But when we add the second, when we take the second one, we find we get a 9, but we wanted a negative 3, so that's not going to work out. So maybe we try instead, let's say 5 and negative 2. So we know these multiply to negative 10, but check this out. When we try to add this, we get a positive 3 instead of a negative 3. So that's a problem. We need a negative 3. So even though it adds up or multiplies up to negative 10, it doesn't quite add up to negative 3. So our last one, the fact that we got the same value but the wrong sign means that we're on the right track. So maybe if we switch our negative sign around, we might get somewhere. So great, we get a negative 10 here. If we add them together, well, negative 5, I owe you $5, you give me 2 back. Well, now I owe you $3. Or I owe you $5, I give you 2, I owe you $3 still. So notice how we have the negative 3 and the negative 10. So that means that one of our terms is negative 5. Oops. One of our terms is negative 5. And our other term is going to be 2. So we can actually put these two values into our factored form. X plus negative 5 times x plus 2. And so this is all going to equal 0. So these two expressions are the same exact thing. We could also say that this is equal to x squared minus 3x minus 10. They're the same exact function. They're the same exact expression showed in two different ways. But now we're saying, okay, this whole thing has to equal 0. So just thinking about how values work, if I have something like, well, I'm going to just do it in this little corner because we're running out of space. But just a number example, if I have 5, and I'm multiplying it by some number so that it's equal to 0, this question mark has to be equal to 0. There's no other way. Same if I do a mystery number times negative 2, and it's equal to 0. That term has to also be a question mark. Here we're dealing with two terms just like we did right here. Our x minus negative 5 might represent this one, and our x plus 2 might represent this number we're working with. So if we want one of these to be any value we want, the other one has to be 0, so when they multiply they get to 0. So we can look at these individually. We can look at two situations, so this is an OR, so in two different worlds, maybe this first one, x plus negative 5 or x minus 5, I'm just combining these two terms, equals 0, so that when we plug it in, we'll get that this multiplies to 0, or we have that x plus 2s equals 0. And we'll check this to be absolutely sure, but here we find that x can equal 5. So our check, we just put in 5 into here, so 5 minus 5 times 5 minus 2 equals 0. Well, this is just 0 times 3. Well, 0 times 3 is just 0, so that helps out. So let's try our other one where we have here subtracting 2 off each side, x equals negative 2. So in this case, we get negative 2 minus 5 times negative 2 plus 2, and that should equal 0 if these are both good. But notice here that instead of the first term being 0, we now have that this is a negative 7. So at first we're starting to panic, being like, oh no, we can't make this a true statement. But notice how when we solve for our other x value, we get negative 2 plus 2, or 0 itself. So 7 times 0, definitely 0. So these two both work. And one last check we can do is actually putting it into our original equation to show that these actually will help us out. So we're up here and we get 5 squared minus 3 times 5 minus 10, that should equal 0. So we'll have 25 minus 15 minus 10 equals 0. And check that out. We get a true statement for our first solution. So let's try the second one. Let's squeeze it right in here. We have a negative 2 squared minus 3 times negative 2. Let's see. Oh, this is going to be a tight squeeze. Times negative 10 is equal to 0. So all I'm doing right here is just squeezing in checking this x equals negative 2 into our original function. So here we get 4. So negative 2 times negative 2, we have a positive 4. Negative 3 times negative 2, that's a positive 6. And then we're subtracting 10 from those positive values, and it should equal 0. Well, 10 minus 10, definitely equal to 0. So notice how in both cases, these two values passed our checks for our factored version. It also checked out for our standard form version. So that's one of the ways. The next one that'll be helpful is the quadratic formula. So the quadratic formula is very nice. It works for every single one. Notice how in this case we had some very specific values that did work out for our game, but sometimes you're not going to have those nice values, so it's worth checking out how this would work out. So our quadratic formula has to deal with our a, b, and c. So your first thing you want to do is get your a, b, and c from the quadratic equation. Okay, so the second thing we do is then take those x equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Okay? So this is what we're looking at right here. And so this is nice because you can kind of bypass all of the tricks we were doing, and then find those x's. You can actually just put your a here, given that you have an equation that looks like this. Okay? So let's do it with the example we did last time. I think this video is running a little long, so I'm just going to do this example, but it'll be really helpful for your next one. Just remember to keep in track of your a's, b's, and c's. Sometimes your answers aren't going to come out nice and neat, and that's okay. That's why we have this formula. So in our example, we had x squared minus 3x plus 10, so 1 x squared minus 3x minus 3x minus 10 is equal to 0, and we might need to solve for x. Find the x values that make this true. So before I jump into this, what might help for your individual work is noticing that this is the same exact statement as this. Okay? X squared minus 3x equals 10. So you might have an equality going on, or an equation. In order to use this quadratic formula, you need to bring everything to one side so that it's equal to 0. So in this case, we just subtracted 10 off both sides. So just a good thing to do. Sometimes quadratic formulas aren't going to be as obvious as you think they will be. So we got 1x squared minus 3x minus 10. We know our a here is equal to 1. Our b here is equal to negative 3. And our c here is equal to negative 10. So we're going to put all of this into our formula right here. So we'll have that x is equal to negative 3 plus or minus the square root of b squared, or negative 3 squared in this case, minus 4 times a, which is 1, times c, which is going to be negative 10. And then all of this goes underneath 2 times 1. Okay, so notice how I just replaced all my a's, b's, and c's with these. So I'm going to go to one color now to really show what's going on. So negative 3 and the two negatives make a positive, so we have a plus 3 plus or minus the square root of negative 3 squared. Negative 3 times negative 3 is 9, minus 4 times 1 times negative 10. So 4 times 1 is negative 4 times another negative, that's going to be plus 40. And then this is all divided by 2. So we can keep simplifying this. This is going to be 3 plus or minus square root of 49 divided by 2. And here we have 3 plus the value that when multiplied by itself gives you 49. So hopefully you all see this is 7, because the square root of 7 times 7 is the same as the square root of 49, and then we're dividing it by 2. So there's two different equations we can have. We can have the one where you add your 3 and 7. We also have the x value where you subtract a 7 from a 3. So if we first do our plus, we'll get that x is equal to 3 plus 7 divided by 2, or 10 divided by 2. Look at that, we get an x equal to 5. Next one we can do is x equal to 3 minus 7 divided by 2, or negative 4 divided by 2, which comes out to negative 2. So here x is equal to negative 2. Okay? So notice how we get the same exact values plugging it into this quadratic formula as we do when we look back at our notes. So two strategies to factor, or to solve for your quadratic formula. Use the one that makes the most sense to you. I would strongly recommend knowing this one because you can start seeing it pretty easily once you get used to it. We're also going to review this a little bit in the future as well. So if it doesn't make sense the first time around, we're going to have more opportunities to look at problems like this. So let me know if you have any questions. I'll probably have you guys watch this before you get started with your last problem.